Hello, good morning friends. Good morning friends. Today we are going to learn our module number 2 vector spaces. Today's topic is projection of a vector. To understand this topic, we need some concept that we already learned in the previous video, that is how to find a dot product of a vectors and how to find norm of a vector. We need these concepts. Okay, so let us see first what do you mean by projection of a vector u bar on v bar. Suppose we have two vector u bar and v bar and we are trying to find out the projection of a vector u bar on v bar. So for this we need one diagram. Suppose this is our diagram where one vector is a u bar and one vector is a v bar. To find out the projection of this vector u bar on this v bar, that is this will be projected here. So what actually we are trying to find out? We are trying to find out actually this line that a line have already drawn. So to find this line, how we will find? We have to express this line in terms of scalar multiples of v bar. Then we'll get this line, and that is called as the projection of vector u bar on vector v bar. How to represent this in terms of formula? So we have some formula. Projection of u bar on v bar is equal to u bar dot v bar divided by v bar square dot v bar. Now here actually we need the norm, and each time instead of writing this u bar, v bar and v bar here, we can remove that bar sign also. Therefore we can write projection of u on v is equal to u dot v upon norm of v square dot product with vector v. Now in the examination only this formula is sufficient. If they ask the question, only use this formula and put the value of uv. You already know how to find dot product, you already know how to find norm, put and simplify to get this scalar. So this scalar times v bar is our projection. The same thing I explained in this diagram. Now let us solve some example. Suppose in example number 1, we have to find the projection of u on v where u is equal to 304 and v is equal to 233. Now what we'll do, we'll first try to find out the projection of u and v, and then we'll try to find out its norm, because here norm is asked some extra question. Doesn't matter. So let us start with the solution. We know that projection of u on v is equal to u dot v upon norm v square dot product with v, and now we'll put the value of this u and v in this formula and we'll get the answer. So let us substitute the values. Therefore projection of u on v is equal to 304 dot product with 233 divided by a vector 233 and its norm square dot product with a vector 233. And now we'll try to simplify this. So to simplify this, what we'll do, let us, the simplification is projection of u on v is equal to 6 plus 0 plus 12 divided by root of 4 plus 9 square dot product with 233. How we obtain this? Now we are multiplying actually this 3 into 2, so we got 6, then 0 into 3 we got 0, then 4 into 3 we got 12, and norm 2 square is 4, 3 square is 9, 3 square is 9, so square root of this number and dot product with 233. And now if we simplify, we know that 12 plus 6 is 18 and 9 plus 9 18 plus 4 22. So in the next step we can write projection of u on v is equal to 18 upon root of 22 square into dot product with 233. Now we can write root 22 square as 22 here, and then only simply a dot product of this number here. By cancelling 2 from here, we'll get 9 by 11 and same vector here. So you got the projection of u on v. Now let us find out norm of this vector. So projection of u and v is equal to 9 by 11 into root of 4 plus 9 plus 9, because we are taking 2 square as 4 here, 3 square as 9 and 3 square as 9 here, and therefore we got this as a vector. And this 9 by 11 as it is, because if we take the square of it, it becomes 81 upon 121. Again we have to take the square root, so it becomes 9 upon 11. So I written 9 upon 11 as it is here. And therefore our answer, projection of u and v is equal to 9 upon 11 into root of 9 plus 9 18 plus 4 22, we can write here, and therefore this is our last answer. Now similarly we'll try to solve one more problem, but in that example we'll add some additional concept also. So what is that additional concept? So here we'll try to find out vector component of u orthogonal to v. How to find it? There are some formula to find it. Now we again use the same concept of projection here to write down this formula. So formula u minus projection of u and v is equal to u minus u dot v upon norm v square dot product with v. Now here we already know how to find this u dot v upon v square. This we already know. We are only subtracting this quantity, this vector, from u to get u orthogonal to v. So let us see one example. Find the projection of u on v, where u is equal to 3 1 minus 7 and v is equal to 1 0 5. Also find the vector component of a vector u orthogonal to vector v. How to do it? To do this, what we'll do here, we'll first try to find out the projection of u and v, that is this vector will try to find out, that is projection of u and v. So for this we can write, therefore we know projection of u on v is equal to u dot v upon norm of v square dot product with v. And therefore now we'll put the values. Therefore we'll get projection of u on v is equal to 3 1 minus 7 dot product with 105 divided by norm of 105 square dot product with 105. Now we are putting only this value of u and v in this formula. We are putting this u and v in this formula to get this expression. Now we'll try to simplify now this expression. This expression will try to simplify now with the help of dot product and norm. Therefore we have to simplify this expression where numerator has the dot product of two vectors, denominator we have to find out the norm of this vector, and dot product with again a new vector. So how to simplify this? The simplification is very simple. In the numerator we have 3 into 1 3, then 1 into 0 0, minus 7 into 5 is minus 35. In the denominator 1 square is 1, 0 is 0, and 5 square is 25 into this vector 105 as it is here. And 3 minus 35 minus 32. In the denominator 1 plus 25 is root of 26. So we can write, therefore projection of u on v is equal to minus 32 upon root of 26 square into dot product with the vector 105, that is minus 32 upon 26 into 105, and we'll get minus 16 upon 30 0 minus 80 upon 30. And now this minus 32 upon 26 we are just dividing it by 2 to get minus 16 by 13 this type, and dot product with 105. So we got this expression. And now only remaining is vector component of u orthogonal to v is. So again we know the formula, u minus projection of u on v is equal to u minus u dot v upon v square dot product with v is equal to, now put the values of u as 3 1 minus 7, that is given in the example, and value of this u dot v is we are taking from this here, and therefore this is just a simple subtraction of two vectors, and we'll get the answer as minus 55 by 13 comma 1 comma minus 11 by 13, and this completes our topic. So today we have learned two different things. That first one, how to find out the projection of a vector u bar on v bar, and second in how to find out the vector component of u orthogonal to v. Thank you.